Uh, Hello everyone. Today we are going to solve the another problem of TSA. So today the problem is rotate list. Actually it is rotate the linked list. So this is problem number 61 of Leet code. So the problem is like this, that we have given the head of a linked list, rotate the list to the right by k places. Means we were given a linked list and we have to rotate the element from back to front. Means suppose we were given 1 2 3 4 5, so 5 will come at first place and 4 will be at last. Then again rotation, 4 will come at first place and then 3 will become last, and corresponding all the elements will shift one place toward right. So I hope that the question is clear to you all, and in this question we were provided with the head node. Means currently we were pointing at the head of this linked list, and k is number of rotation, that how many rotation we have to perform. So I hope that the uh, problem is clear to you all. Sorry. So let's discuss the logic of this question, that how we going to solve this and what will be our approach. So linked list is quite similar to array. Array is also a linear data structure and linked list also. But in this, what is given, that every node, means every number is connected to its next element. So we have to be extra careful and we have to apply some other logics. So let's see how we going to do this. So firstly discuss about the base condition. Okay, suppose that if the value of k is suppose 43, 48, something like this. So we know that if this the length of this linked list is 5. So suppose we perform rotation, we put 5 at, look, 5 at first place, then 4, then 3, then 2, then 1, and again 5 will came at last. So we know that we can observe this thing, that after every rotation, when the rotation reach to its length, means the length of linked list, so the linked list will going to repeat its same position. Means the linked list will repeat its current state at which it is now. So it is useless to perform rotation up to 48 times or 49 times or 10,000 times. It is completely useless because it will going to repeat its same state this after every rotation when reach to its equal, when rotation reaches equal to its length. So we can see that rotation will equals to number of rotation. If they are more than the length of this linked list, then k equals to k mod ln. Here ln is the length of this linked list. So it will give the exact number of rotation that we need to perform. Suppose we were given 45 rotation. So we know that after 45th rotation, when we perform the 45th rotation, the linked list will reach its original state because the length of this linked list is 5. So do we need to really perform any rotation? No. So how many exact rotation we need to perform? It is equals to k mod ln, where ln is the length of this linked list. It is given the exact rotation. Now came to one more thing, that we have to perform the right rotation. Means we have to shift the last element to first place. Now observe that number of right rotation is equals to length minus number of rotation means number of right rotation equals to left rotation. How it will? So let's see one example. That suppose we need to perform 3 right rotation. So the linked list will become something like that. First 5 will come, then 4 will come, then 3 will come at first place. So the final linked list will become like this: 3 at first position, then after that 4, then after that 5, then 1, then 2. Now see how many left rotation will equals to 3 right rotation. Let's check it. So if we put this 1 to this last, then this 2. So we can see that if we perform 2 left rotation, then it will become equals to 3 right rotation. Means number of left rotation equals to length of list minus number of right rotation. Now why I'm converting it to right rotation, left rotation, this we will understand when we will discuss the original logic part. So let's discuss the base conditions again. That what will we have to do first. First we have to check that if value of k greater than length of linked list, then we will make k equals to k mod ln. Then we will convert right rotation equivalent to left rotation. How we will going to convert it? Length of linked list minus number of right rotation. We will get the equivalent left rotation. Okay, now came to our main logic part, that how we will going to solve this problem. So up till now we get our number of left rotation. So now implement a loop. Since we have to perform left rotation, so let's implement a loop up to k minus. Suppose we want to perform equivalent to right rotation, so it is equivalent to 3 left rotation. So now 3, as we know that 3 is our equivalent left rotation. So how we will going to do this? We will implement a loop up to k minus 1 time. Okay, so how we will going to do that? So for the logic, the first thing we have to do this, we have to make this linked list circular. So now how many right rotation? So let's take rotation equals to right rotation equals to 2. So number of equivalent left rotation equals to 3, because length of linked list is 5. So the final output would be like this. This 4 will go to here. This 3 will be at last, and after this 3, it is point to null. So this will going to our final output. Okay. So as I said this, the first thing that we have to do, we have to make this linked list a circular linked list. Means this 5 will point to this 1. Okay. So as per our logic, first we have to make this linked list circular. So now this 5 is pointing to this 1. Now we will start traversing from this 1. We will start traversing from this 1. So we will traverse up to 3 times. So we will came over here. We will stop at current. We will stop exactly at this 3. So how many rotations we have to perform? So suppose current equals to here. So for first current equals to current dot next. We came over here. Current equals to current dot next. So suppose left rotation equals to 3. So we came at this 3 in k minus 1 rotation, means just in 2 times. So we reach over here up in k minus 1 time. So we implement a loop and we came to at this 3. Now what we will do, we will point our head, means the answer which we will going to print. So we will point our head to this head dot current dot next. So now current is over here. Current of next is 4. So we will point our head is over here. So now our head is pointing over 4, and now we will make this current dot next equals to null. So now this 3 will start pointing to this null. And finally, we will return head for printing. So the head will print something like this. It will start from 4 because head is currently pointing to this 4. 4 is pointing to 5. So 4, 5, and we have already made this linked list a circular linked list. So 5 is pointing to this 1. So 4, 5, 1, 2, 3, and 3 is pointing to null. So finally it stops over here. Since like this way, we will reach our output. So I hope that the logic is clear to every one of you. So now came to the coding part. So firstly, we have to perform all the base conditions. So we will check if k equals to 0 or head equals to none. Suppose we don't have to perform any rotation and head also none. So we simply return head. Now we have to perform some operations. So we will put current equals to head and take length ln equals to 0. So we will do something like this. We will implement a loop to find the length of this linked list while current does not equals to, sorry, we will do something like this while current of next. Now why I'm doing current of next? Because we have to make this linked list circular. So while current of next does not equals to null. So at the point we reach up to the last element, we will start pointing to the first node. So like this way, we will make this linked list circular. So as we came over here, ln plus equals to 1 and current equals to current dot next. So finally we came over here. So now at this position, our current will reach to the last element. So current will reach to this 5. So now we will start pointing this 5 to 1. So what we will do, we simply write current of next, current dot next equals to head, because head is still pointing to this, sorry, this root node, this head node. Head is already pointing to head. So now 5 is pointing to the 5 is pointing to 1. So now after this, what we will do? So current of next equals to head. We will make current equals to head. So now both head and current is pointing to 1. And finally, length equals to length plus 1. Now why we have done this? Because since we are traversing over here, so it counts one element less. If we have 5 elements over here, then it counts 4. So that's why I did plus 1. So now we will check our second based condition if k is greater than length of ln, length of linked list. So if k is greater than ln, then we will make k equals to k equals to k mod ln. This thing we have already discussed in our logic part. Now we have to make our right shift equivalent to left shift. So k equals to ln minus k. So our right, so firstly we make k equals to k mod ln, then we make our right shift equivalent to left shift, that is k equals to length minus k. This also we have discussed. So as I said that now we will shift our current to k minus 1 time for I in range k minus 1, and simple current equals to current dot next. Now what we will do, so let's see. By implementing this loop, we came over here, this 3. Now current is pointing to this 3. So what we will have to do, we will shift our head to this 4. So what we will write over here, head equals to current dot next. Next. Then since we are at 3, so now what we will do, we will point this, the next of this 3 which equals to null. So now we will make current dot next equals to none, and finally we will return head, because printing will start from 4. So head is pointing to 4, current was pointing at 3, current was at 3, and so next of current is pointing to none. And we have already made our linked list a circular linked list, so it will print from 4, 4, 5, then 1, then okay, the base, then 1, then 2, and 3, and 3 is pointing to null, so it will stop over there. So why this condition gets so over? Let me check over here. So the mistake is over here. If k is greater than equals to ln, so let's run it again and submit it. So now the logic is completely fine. Let's see the C++ solution also. So this is same as Python that we have discussed, only there is a small change in syntax. So this is also works completely fine. We can see over here base condition and everything same looping conditions and same return head. So thank you for this. Thank you for watching. We will meet again with a new problem of TSA. Till then, keep learning.